All right, good evening everyone, and welcome to this special event hosted by the University of Virginia Center for Politics. My name is Chris Krebs. I have been a scholar with the center for several years now and just recently joined the board of the Center for Politics. I am a 1999 graduate of the college, George Mason University Law School. I guess my most recent claim to fame or notoriety is that I was the director of the Cyber and Infrastructure Security Agency in the U.S. government within the Department of Homeland Security. And I was let go of that position very publicly. So you may have heard that story. But that's not why we're here tonight. We're here tonight to talk about artificial intelligence. I think the average person is probably not thinking about AI on a daily basis, but how many times in a day does it come in contact with their lives, with your lives? What are the benefits associated with AI today and tomorrow, and what are some of the potential risks? In the short term, the benefits seem limitless, but in the long term, particularly when we hear some of the real, the vanguard of generative AI and beyond, when they talk about the existential risk, what are some of those potential impacts on our lives? So today with us, we've got an amazing group of experts sourced locally here at the university. And then we have my friend from DC, Katie Harbath, that I've known for quite a while now. So we're going to talk about what's happening in the world of AI, what the benefits are, what the risks are, and then what should we be thinking from a policy perspective? What should DC be thinking about? And you'll hear from the panel, and you'll also hear from me. I've worked quite closely with the U.S. Congress over the last several years, and I have my own views on what we're actually going to probably be able to accomplish from a policy and legislation perspective. So our first panelist for the discussion is Dr. Madhur Bahl. He is an associate professor in the Departments of Computer Science and Systems and Information Engineering, and a member of the Cyber Physical Systems Link Lab at the University of Virginia. Dr. Bahl conducts research at the confluence of machine learning, predictive control, and artificial intelligence with applications in cyber physical systems, autonomous systems, robotics, and smart cities. We'll talk about self-driving cars at some point, I'm sure.
I'd love to.
He's the team principal of the University of Virginia's Cavalier Autonomous Racing Team. Dr. Bahl received his PhD and MS in electrical and systems engineering, both from the University of Pennsylvania, and his bachelor's degree in ECE from PEC University of Technology in India. Next, we have Fernando Fioretto, who works on machine learning, optimization, differential privacy, and fairness. His recent work focuses on the integration of constrained optimization and machine learning to enhance the expressive ability of machine learning models and understanding the interplay among privacy, equity, robustness, and performance in machine learning models and decision tasks. He is a recipient of the Amazon Research Award, the NSF Career Award, which I believe you received as well, the Google Research Scholar Award, the Casper Boden PET Award, the ISS NAF Mario Gurla Young Investigator Award, the ACP Early Career Research Award, the Best AI Dissertation Award, and several Best Paper Awards. He received his BS from the University of Parma and his PhD from the University of Udine and New Mexico State University. Next, Katie Harbath. Katie is a global leader at the intersection of elections, democracy, and technology. As the chief executive of Anchor Change, she helps clients think through tech policy issues. She's the director of technology and democracy for the International Republican Institute, and is also a fellow at the Bipartisan Policy Center, the Integrity Institute, and a non-resident fellow at the Atlantic Council. Previously, Katie spent 10 years at Facebook as a director of public policy. She built and led global teams that managed elections and helped government and political figures use the social network to connect with their constituents. Katie holds a BA in journalism and political science from the University of Wisconsin-Madison. Finally, we have Yinling Kuo is an assistant professor at the computer science and a member of the Link Lab at the University of Virginia. Her research interests lie in the intersection of artificial intelligence and cognitive science with a focus on integrating them into robotic systems. Her work develops machine learning models that provide robots with generalizable reasoning skills to interact with humans, including language, understanding, social interactions, and common sense reasoning. She received her BS in computer science and information engineering and her MS in computer science and information engineering from National Taiwan University. She earned her PhD in computer science from the Massachusetts Information Technology. So thanks to everyone for participating in this timely discussion. And with the formalities over, I think we can get into it. So I think, particularly with where we are right now, you can't have any conversation without a little bit of baselining on what it is, where we came from. It certainly seems like, at least in the last 10 to 12 months, that AI kind of came out of nowhere,
right,
and overtook the entire national dialogue. And I'll tell you from my experience as a consultant to a number of Fortune 500 companies, this wave hit or crashed upon major corporations in the earlier part of the year, where every company was thinking about the cloud migration and digital transformation.
Right.
All of a sudden it jumped to AI everything, AI first. And you saw it in budgets. Yeah. Budgets shifted away from cloud transformation into AI. And it actually was quite similar to, as I saw it, the 2011, 12, 13 time period when cloud first really hit the space and everybody was maximizing their Amazon Web Service. But the bigger point here is that AI, in fact, is not new.
Not at all.
Right? Neural nets have been around for decades, conceptually and in practice, and then machine learning. And the difference here is that we saw the commercialization of it, where it's readily available. So let's start a little bit there and kind of roll back the clock. Okay. Madhur, we'll start with you, and just give us your take on where we came from. How did we get here? We'll talk about what today actually looks like next, but why don't we start with what led us here?
That's a great place to start. And like you said, everyone has a different notion and understanding of how we got to ChatGPT. So we can roll the clock back to, there was a time when dinosaurs were, we don't have to go all the way back. So it's not that long. But I will start by saying that the quest to understand human intelligence and to build machine intelligence predates even the invention of computers. This is a question which is up there. How does the brain work? What is intelligence? Is right up there with, is there life elsewhere in the universe? How does the universe work? And this is such a profound question of what intelligence is, because you're trying to understand the brain, which is the means through which you understand everything, right? So it's something deep about that itself. And so when you try to understand something, it's a good idea that can you try to create it yourself? That'll give you the understanding of how the thing works. So that's what researchers did. They, in the early 90s, they observed that biological neurons in our brain, they exhibit some spiking behavior when the brain is tasked with activities like speaking or moving your limbs, or even just looking at the world is exciting some neurons in the brain. And that was a groundbreaking observation. And you can then fast forward to, I would say mid-1950s is when the artificial neuron was essentially a mathematical attempt to replicate this spiking behavior of a biological neuron and mimic this network in the brain. And that's why we have the name artificial neural network. It's literally trying to just replicate our understanding of how the brain works. And it's very interesting because you hinted upon the cyclical nature of technology. Even back in the 50s, there was this hype of, we've solved intelligence, it's around the corner, machines will be in every household. But we didn't deliver, or AI didn't deliver on that. And there was fundamentally things which were missing, and this overly promising and predictive hype led to a very immediate decades of skepticism. And now in retrospect, we call this period like a AI winter, because the field came to a standstill and many people left the field. There was no funding and there was in general not a whole lot of enthusiasm, but Now we also think it was needed because it provided some much needed introspection and focus for the entire field. And this happened until the next remarkable thing came up to the scene, which is this little thing you may have heard of called the internet. And so, this vast spider web of connecting thoughts, ideas, and people from all over the globe. So internet was more than just a means of communication. It became this repository, this ocean of information. Internet became a way to transcribe humankind, because when we interact with it, we are expressing our nature and our intentions to this digital world. And so maybe that became a watershed moment. Now we have the data. Certainly machines are around the corner and we'll have our self-driving cars, but not quite again, because I would say we had the map of how to navigate this ocean in terms of artificial neural networks, but we were missing the ships to navigate this ocean. We didn't know how to traverse this data yet. And so another winter came upon this entire field in the 80s and the 90s, until, after every winter there is spring. And so the spring arrived in the form of, I would say, very powerful computation chips, which we call GPUs. And they allowed us to traverse this ocean of human knowledge in a very efficient, fast way, energy efficient way, as well as time efficient way. So we, for the first time, could actually ingest this data which was getting created. And that revolutionized so many fields. You just name a field and you have AI in it: healthcare, drug discovery, transportation, sustainability, manufacturing, supply chain. Every single aspect of our society got penetrated with this technology. Yet something wasn't really human intelligence, which is that original quest. And so the cyclical nature repeats, and we've been riding this curve since the last 2 decades, as you correctly observed. And so I'll fast track to now where we are today, so we can move forward for the rest of the evening. So GPT on ChatGPT is just a special type of neural network. It stands for Generative Pre-trained Transformer. It's just a special way of connecting these very artificial neurons which have the spiking behavior. Of course, we've gotten better at understanding a little bit and trying different things and what works. And combined with our ability to traverse, let's say, all of the text ever written by any human ever existed, which is the internet. If you teach this neural network to go not just explore all of the text, but also the depth of the ocean of human knowledge, that's what we are seeing in terms of this large language model called ChatGPT. And maybe to bring this history to some resolution, I think it's important to point out that, think about how we teach a child how to speak. We teach the child a few words to begin with, and then they can repeat those words. Maybe they can repeat a sentence, they can mimic what their parents are saying, and they can even recite an entire nursery rhyme. They may not necessarily understand the meaning of what a twinkle, twinkle, little star is, but they can certainly recite it. And that's what ChatGPT is doing today. It's gotten so good at mimicking and reciting patterns of data and predicting what the next sentence, the next word should be. It's essentially a parrot, which is so adept at mimicking human language that it can hold a conversation with a human, and we feel that it has some deep understanding of how the world works. Yeah.
So before we get further down the ChatGPT lane, I do want to bring Fernando and Yinling into the conversation about the history. And we've heard about, you mentioned GPUs as a big kind of accelerant and compute capacity and power changing the game and getting into more training. But what led us up there? What are the critical elements that accelerated the development of AI? So Fernando, happy.
Yeah, so I think that there's a couple of factors. There's a large availability of data. Essentially, a lot of models that are powering neural networks, they are regressors. So they are navigating this huge space of data and represent it in very high dimensional spaces, and then try to find very complex correlations that exist across this data. And so we have seen this, for instance, in visions. Vision models now, they are really, really good in distinguishing several aspects that you can see in an image. So like in segmentation, for example, this is something that power modern autonomous vehicles. You can distinguish pedestrians, you can distinguish other vehicles, and you can recognize all those things. Those are models that have been trained that recognizes those type of patterns. And that could not have existed if we did not have this large capability of saving this data, storing this data, and then giving this data meaning. So transforming it in the language that the neural network can, or the models can actually understand and process. And the other is obviously computational, because in the past, I mean, at the bottom line, the operations that you're doing in a neural network or simplistic ML models is just a chain of very, very simple transformations. So there are just some multiplications essentially that you're doing, and some other operations at the very core. But those operations, they become very, very complicated when you have very large amount of data which translate in large dimensions. And thus, the use of GPUs here, or the use of sophisticated architecture TPUs, has definitely speed up the development of new algorithms as well as new performance architectures. So this was a little bit also maybe primitive, because right now we have seen a jump in models and architectures. So there was a lot of research in algorithms. What you're doing in this space of solving, so in the space of learning, it's really solving an optimization problem. You try to correlate all the inputs with some labels, so what you would like those inputs to be related with. And so you try to really look at those dependencies through the lenses of an optimization problem, which minimizes something. But now architecture, so the researchers focused not only in speeding up and making those optimization algorithms better, but research has also been focusing on how to transform really those architectures, this neural network infrastructure. And so, for example, in visions, we are not seeing anymore only CNNs, which are typical visions architectures, but right now diffusion models, for example, or certain type of transformer network, which are complex architecture, are being used in vision tasks, and we're seeing huge advantages in using them. The models powering ChatGPTs are transformers, which are complex architectures. And so what this means is also that those architectures have shifted the focus on try to understand how those algorithms work. So there were, once again, statistical methods and optimization methods that we could comprehend. We could understand the rate of convergence of those algorithms. We could mathematically understand how those algorithms were working through something that is much more opaque and something that it's much more black box, right? And thus this is impeding us also the ability of really understanding how those models are behaving. And this is another really hot area, which is that of ethical AI or responsible AI, which is an area in artificial intelligence and machine learning that encompasses all what is related with those aspects that you don't expect the models to actually touch upon. For instance, unfairness in some of the downstream tasks that you might power with the use of AI technology, or privacy violations or security violations, and so on. And I think this aspect, it's important because AI is powering a lot of decisions that we're making nowadays, right? So when you move from one place to another, when you're deciding how funds are going to be allocated, when you're deciding how to hire a person, there's essentially a small AI algorithm that runs behind the scenes, and those decisions that you're going to get, they are reverberating certain type of biases that might be present in the data, that might be present in architectures, or all this type of complex infrastructure that we're building that we don't yet understand, right? And so I think that this is, brings me up to today, which is really, we as researchers in AI are really trying to understand, what's inside those boxes that we are building. I think I can stop here. Maybe I can just mention that there was. I think AI is making huge progresses not only in maybe some areas that are evident to the most, like in language translations and so on, but it's being utilized also like in medicine. It is so in the healthcare sector, in molecular biology. So there was another area of artificial intelligence, which is called reinforcement learning, has been used by several, but predominantly DeepMind has been key in this type of research field. And there have been a couple of developments. AlphaStar, which was basically a reinforcement learning algorithm which learned how to play sophisticated games, as well as an extension of this which learned how to fold proteins, which are very sophisticated biological entities, which is now leading to biological discoveries which were unprecedented before. So a lot of benefits in this side.
And I'm going to come back to you in just a second to talk again about kind of where we are and what does the industry look like from an practical perspective. But real quick with Yan-Ling, you're going to lead off the conversation about what the future of AI holds. But I'm a big believer. Yeah, right. Well, I'm a big believer that if you don't know where you came from, then you're going to have a hard time getting where you want to go. So what's your view on kind of the build up to today? And maybe, because we're about to talk about who the players are today, are the players of yesterday different than today?
Yeah, definitely. I actually want to go back to talking about the cycle, the nature of AI, because this is not the first moment AI is a big thing. So when you're talking about long time ago, like Deep Blue, when they play against the human chess player, they win. That is a very big news. And I think all these are big challenges, highlight something like the AI system has some big breakthrough and learn something, and then people try to use this learning and apply to the real problem. It's that, oh no, it doesn't work. And since it doesn't work, then we improve again and then find another challenge to see, okay, does it solve the next challenge? So for example, the first one, the Deep Blue people figure out how to use AI to very efficiently search this huge rules among how to do chess playing, and these are all about those expert system, rule-based AI. You can do this very fast, quick, and solve it. But later, we realized quickly all this understanding of rules cannot really transfer to real world, because you cannot write all the rules. If you are doing law making, definitely you cannot write down everything, right? So they also come into later, you are trying to, at the internet, you get more data. So maybe you all remember about IBM Watson, they win Jeopardy. That combination is kind of you utilize the rule-based and the search, but plus the big data they have that time. So you kind of archive all the search like a Google search engine, but you are doing it locally. So you can do it very fast and associate and win human player. And I think at that time, some of you may remember on the news, people say, oh, IBM is gonna to take Watson to hospital to replace doctors. But how many years we've been so far? So I think when you start to bring this AI system into the application area or the domain, you start to realize this AI system, although they are quite good compared to the previous version, but they still overlooking something. So for example, that time we figure out, okay, even though we document those things when we interact with doctors, you still don't have enough those clinical data and how to learn it efficiently. And I think later you also remember DeepMind, Nando just talked about when human Go player, and which is actually a combination because of the GPU data and the search. All this happened in before, and we combine together. So that's why you can win the human Go player. And I think several years ago, everyone also think about after that, all the radiologists are going to replace, because we're going to use AI to read our medical images. But still, like, we still don't have that happen quite ready yet, because all the really bring AI to the real application, you not only consider the algorithm itself, but also like how you collect the data and how you like build up this pipeline and make sure it's updating correctly, and including like the privacy and fairness, and how does it work with like the hospital workers who really like involved in this process. So there's actually more than like building algorithm. But I think fast forward, if we are talking about today, ChatGPT, I think ChatGPT is like a continuation of this. We are like building another like holy grail we want to pursue, and we are combining GPUs, data, and much better algorithm and model and computation. And but I think one thing that's very different from before is before, even when we're talking about AI, it's more like something is behind like a big machine or a big corporation. So no one can really touch it, even that they win a lot of big things. But now with ChatGPT, it seems like, okay, really quickly, everybody can go online and play around with it, asking questions. So you kind of know, okay, what AI is really doing, what kind of question they can answer. So you understand what's their capability and maybe also like limitations, because you can, probably some people try to ask them question and figure out, oh, they just talk about gibberish, but sounds logical, but not right. But I think this is actually a good thing, because it's kind of a moment we like democratize AI, so like people can really try it and know, okay, what is AI is about, and thinking about what could be the next step to move forward.
And I definitely want to come back to that point, particularly as it comes to open source models as opposed to closed and proprietary models. But what kind of struck me as maybe one of those generational leaps in AI over the last couple of years is you talked about DeepMind and chess, and then you talked about Watson and Jeopardy. And those are two completely different problems, where the chess is pure math. You can look at the potential pathways to victory, and it's probabilistic on how it plays out. Watson, on the other hand, requires context.
Correct.
And I think that's where we are today, that's so different about natural language processing as it comes to.
It is different, but I'll tell you what the lowest common denominator is. Between chess and language, it's patterns. And these are pattern recognition machines. And so you could argue that language is open world, like chess has closed doors, just these set of finite rules, how the pieces move about. And language is more rules, thousands of rules, but still finite rules, right? The dictionary, the number of root words are what, for 50,000, 60,000, 100,000? They're still finite. And we are good at learning patterns. That's what's happening.
So that's the perfect transition, I think, to really a deeper conversation on where we are today. So we've already talked about ChatGPT, but let's take it up a level and let's talk about just generative AI. What is it, right? We've heard a lot about math and what you just said. You can, there's a lot of predictability here, but Fernando, let's start with you. Ultimately, what is generative AI? What's like the simplest way to describe it? And I think about it as just like predicting the next character, what is it?
Yeah, so that's a good way of describing. I guess if I have to describe it in my own words, generative AI is the capability of transforming an input, which might be anything, like white noise, into something that it's predefined and we would like. For instance, images, right? So generative AI algorithms like DALL-E 2, and so on from the OpenAI, where they are essentially working on some sophisticated models, some diffusion models that are essentially doing that. They are blurring some image more and more and more, and then reconstructing that blur that they have put it into an image, so that they are learning the patterns that arise when you're trying to blur something into what you're trying to reconstruct, right? And that then is merged with the capability of identifying, what is this textual representation of the prompt means when I'm looking at those images that are associated with it. But fundamentally, generative AI is this capability of generating something. in the high-level domains. And this is very different from what AI capabilities have been since maybe a few years back, because we call those predictive AI. So you have maybe a Boolean attribute. You want to predict whether an individual would be able to repay their loans or not. That's Boolean variable that you're predicting yes or no. Here you're predicting something in a very, very high dimensional space. An image has many pixels with many depth and so on. So this is a completely different framework. What you talked about, the predictions of the next word, the next token, those are modern generative AI framework, autoregressive models that are essentially associating one word to the next and so on. And I have a story that I think it's interesting. Like when this word started, researchers, I think they were off at Google, they wrote a paper about how to map words into vectors. So they look at several words, dictionaries, and so on. And what they wanted to do is, we want to do math, right, in the end, because neural networks, remember, they are just doing some math transformations behind the scenes. But those words, how do you represent them in some mathematical language, in some numbers? And so they started doing that. They started transforming those words into numbers, into vectors. And then they realized something really surprising. When those words, when you were clustering words that we consider proxima, so for instance, you might consider, alum, scholars, and so on, all those type of words that are proxima to one another, they were actually mapping into a space of those vectors that were closer than words which were far apart. Not only that, they started to understand that you could do some mathematical operations with those words. Like, for instance, we're doing operations such as maybe you have king plus females, and this would give you queen. And so this was really surprising. This was just a byproduct of mapping words to vectors. And I think this is where it all started, because you have this very powerful representation.
So just a quick follow-up, though. We heard about GPUs earlier. What is the significance of GPUs, particularly in the context of parameters? What are parameters for training? And why do GPUs matter for today's modern generative AI capabilities?
Yeah, good question. So a parameter, a neural network or a machine learning model is a model that learns to do something. If you think at a program, an abstraction, so a normal program that you would write, you would take an input, something, you give it into this program. Let's say that the program is just computing, right, the sum of two integers, so of two numbers. You give it two numbers, and the program gives you an output, right? And this is just the classical definition of any function, of any program. A machine learning program, instead, what it does is you give it the inputs and the outputs, and it needs to figure out the function, right, this program. The complexity of this function is determined by the number of parameters that this model has. The more parameter you have, the more ability you have to represent the complexity of those mapping from inputs to outputs. And the parameters defines cost in terms of computations, because you have this sequence of mathematical operations that you need to make to transit from inputs to outputs. And GPU really help us in parallelizing those operations.
So this is where, when Sam Altman talks about his product roadmap and the lack of access or ability to obtain additional GPUs limits features, limits future models.
That's right.
Okay. Yeah. So let's, Yinling, before we get into the future piece, you've could have already mentioned a couple different products or companies. So what's the landscape look like today? Who are the big players? It's remarkable how much money has flowed into AI, just the foundational piece, not even the application or the appifying it. Mm-hmm. So who are the players right now? Who's really driving the innovation in the space?
Yeah, I think you can talking about like player in in the application domain. So like we can talking about generating in terms of images or generating in terms of like languages, right? So like traditionally, you can see those big tech company, they are definitely invest on these things. So like Meta, Google, and Apple, they all have their team working on like generative AI and the AI research. But I think there are like several like new companies, they are like coming up. So like for example, Nando talking about generating image like a diffusion model. So like there are a couple of companies, people have tried their service like Stable Diffusion or Midjourney. They are like big players for those right now. But I think there's also another several like for like a large language model, for example, like I think Anthropy, yeah. So they are pretty big, even though they are still startup. And also, like, I think we always overlook things like building the infrastructure. So for example, we're talking about open source. So like Hugging Face is actually one of the very big like open source and an infrastructure player for people to share models. So like it is actually encourage like people to do like model discovery and like development on top of that. So that is actually like boost up a lot of like acceleration of the AI research like nowadays. Like whenever you're talking about looking for like GPT or what's the latest like Llama, like you are like going to Hugging Face, this kind of an open source like model sharing platform in order to like find out how to use that. Yeah.
So I'm glad you kind of landed where you did because there was a couple months ago there was an internal memo to Google that was allegedly leaked, but it was effectively titled for Google is "We have no moats." And in the technology space, a moat is really your differentiator. Why do you have lock-in? Why do you own the product market fit? And you're going to own that space. And so the idea here was that Google, at least this engineer allegedly, determined that the closed proprietary model was going to lose to open source models. Yeah. And I think the sub lead here is that it was Google saying we have no moats, and neither does OpenAI.
Yeah. But OpenAI has a very oxymoronic name now because their name says OpenAI, but they're not, outsourcing their.
I'm sure Elon Musk would like to talk to you about that and agree with you. I guess he has his own AI firm now, XAI is it? So anyway, talk to us a little bit more about the delineation or the difference between a closed model and an open model, maybe. Yeah. And where is that? What does that matter? What's the big deal?
So why do we care that big breakthroughs are open source? Because there is precedence that open source software today runs all of the internet, runs on open source. Okay, so roll the pages back and you'll see Sun Microsystems was trying to be the internet company of the world. And then they got shut down, got acquired by Oracle. They exist in some form. Microsoft wanted to be the internet regulators or the monopoly. That didn't work out. The internet runs on Linux, which is open source. So open source is a way for everybody to improve collectively, right? Somebody will fix something, and if something is broken, it can be fixed by the collective power of all the researchers and developers out there. And so same is true. Like, where did these developments come from? Sure that OpenAI and Meta, there's smart people who came and did PhDs, went to those research labs, but the ideas of what a transformer is came from a research paper in like 2005-ish. Attention is all you need. It's a very famous paper. Then it was follow-up work from Stanford. So this science moves in this peer review process, and if your system is not auditable, then we don't really know what it is doing, right? So open source enables not just an improvement curve, it also enables this inspection curve, which seems, because now we have AI at our fingertips with GPT, this feels like there's an urgent need for this kind of transparency and auditability. And so therefore, I think that's one reason why we favor open source, but also there's another delineation which is not enough talked about. You can open source the model, but nobody, I think, I'll be surprised if anybody open sources the data on which they train, right? That's even not on the debate anymore today. But that's where the model is deriving its pattern recognition. That's where really the sauce is. And there's a very interesting thing that it turns out that if you let the model loose over all of the internet, and it can learn without caring about copyrights and all the legal stuff, so nobody talks about it, but if you let the model crawl the web and pick up any image and try to learn patterns from any image, regardless of copyright claims, it turns out it's a better model when you try to work with it. And when you restrict even the data set on which the model was trained, it struggles to keep up with this vast model. So I think to have, it's a technology that everybody should be vested in. So it has to be, I feel, open source. Now, it will be delusional to say that open source doesn't present any risks. I know that's sort of the theme why we are here today. And nobody is suggesting that. But these are problems that we have been solving. Time and again, there were risks with every technology, from the very first technology, which is fire. It could be misused or used correctly, and we have always found ways to use it responsibly. So AI is not for the machines, it's just to amplify humans, and it's humans who are good or bad, and that's what we have to discuss and get right.
That sounds somewhat like the effective accelerationism concept, right?
Sure.
Technology, that's kind of where I am too. It's that you can't hold technology innovation back. And if you do, you end up kind of where Europe is,
if
right?
If you put it behind lock and key, somebody will still develop it, and you will be just left behind. So your advantage as a nation or as a society is to be ahead,
right,
and solve these safety challenges, solve the bias, the ethical challenges. Right? These are challenges we don't yet know to solve, but there have always been challenges we never knew how to solve, and that's what science is all about, right? Let's just solve these hard problems.
I did not check before the panel, but I'm assuming that the three of you did not sign on to the 6-month AI development pause. No. Okay, good. Yeah, it was silly, right? Because if we do it in the U.S., no one else is going to do it,
Right.
And so we lose 6 months of innovation. All right. And Katie, I'm going to turn you loose in just a minute. So
this is the science portion of it. I'll do the good old politics side of it. Yeah.
This is where you bring like the risk management and policy people in to kind of shoot holes in where we're going here. All right. So now this is kind of the fun part. So where are we going here, right? So we've talked about generative AI, but at the same time we have that 6-month letter or the 6-month pause. That the implication is that where we're going with artificial general intelligence and superintelligence, and this is backed up by conversations or comments that Dario from Anthropic has made, and Sam Altman from OpenAI has talked about. There's like a 10% chance that we destroy the human race with the path that we're going with superintelligence. So, Yanling, you get to start the fun part here. Where do you see us going in getting to AGI and superintelligence, and what's that pathway, and what are the critical enablers? And to your point, what are some of the interventions? We'll get to the policy interventions down the road, but what are the things that are going to keep us from getting there?
The guardrails. We need guardrails on there.
Yeah. So I think the path toward AGI is actually still many unsolved challenges. So if you're thinking about what's
for real quickly though, what's AGI versus Gen AI? It gets a little confusing sometimes. So what are we talking about?
That is actually quite confusing because by the definition of we're building AI, we want to build the machines or the agents people in academia are calling. They can do things people originally can do, write, can drive, can respond, can make decisions. So they already think those are things people already can doing. But later, people invent a word called AGI. So probably, I think the main context was about when we're talking about AI, a lot of times we are talking about specific challenge, or long time ago, writing, natural language processing was thinking about really difficult problem for AI, but now we have ChatGPT, so people probably don't think this is difficult enough questions. So now people have this general intelligence, are thinking about what are the other capabilities of humans, like you can interact with other people, can like doing like help or like driving on the road and like making like difficult decision or simple decision. And if you can train a model, they can do all these things together, and we are thinking about it's like a general intelligence. It is not the intelligence that you are designed specific to just looking at the medical images or like law documents or like just recognize objects, because these are not general enough. So that is one of the reasons that is a general thing in the AGI. But in terms of generative AI, I think that is one of a capability we are thinking about, like a machine or human can do, right? Because human, we always generate something, like I'm generating my speech, or like the content. Or like when I move around, I'm generating my emotions. So I think generative AI definitely is one of like the enabler in terms of doing the artificial general intelligence, but there are still a lot more things when you're thinking about one thing. Maybe some of you, like your 3-year-old brother or sister or like young kids, they can do. But nowadays, can you ask your AI to do that? Probably you can think about tons of the things, like how can you navigate, like play around with toys. Nowadays, we still don't have the AI, they can do that. Yeah.
Yeah, actually one way to think of what general intelligence is. So, forget general intelligence. We don't even agree on what intelligence is.
Yeah.
Right? Everybody has a different perspective. Is cat intelligent? Of course, many people would say yes. Is ChatGPT intelligent? Yeah, it's a 50-50, right? So from a computing perspective, you can break down the pillars of the triads of intelligence into language, vision, and physical intelligence. So language is what we have made the most progress in. Vision is where we are applying the same ideas. But all of these models, all of these transformers, they do not understand how the world works, right? So kids and babies understand that if you push an object, it will fall and break, or if you remove something and do ta-da, they know that it's still behind you and they're surprised, and they learn this mental model of how the world works, which is how we are able to drive, which is how we are able to clean tables after we finish a meal. AIs are not even close to having that level of human level intelligence. And that's kind of the AGI is this moving target, this goal that someday we can have autonomous machines or agents that can not be designed to solve one problem, but you have a robot today that can weld Teslas in a machine. It's a very complex task. But if you put that robot into another factory, it's not going to work. You have to redo all of the things. So there's no general intelligence even for a complicated task. It's the mundane stuff which requires this common sense that we call, and these models lack that. And so that's what researchers are trying to fix, because these models are not able to plan their action, which we plan. When I'm speaking, I'm planning ahead. I'm not just predicting the next word. I would be so inefficient, and I would probably slow down my pace by a factor of 50. So these models don't plan their actions. They cannot recover from failures. So there's still very unsolved problems before we get too close to human level intelligence.
Fernando, let me give you an option.
I don't have much more to add. On the concept of general artificial intelligence, I think that was a great explanation. What I tell to my students in class, I teach Intro to AI or Artificial Intelligence here. This is probably one of the courses that I have to modify every year, because I have a slide, that says what AI can do
every
today.
Semester?
Maybe yes, now every semester. So there is one point in this slide: can AI do your laundry? Oh, how I wish. Yeah, that's we don't have that capability. We don't have that mental model in an AI agent to let you do your laundry or your dishes and so on.
But all right, so like lightning round, let's predict.
Okay.
How long
Before
till
what?
AGI, whatever your definition of AGI is.
Yeah, I mean, any prediction which is 5 years out is basically a guess.
Worthless.
Right?
Yeah.
So it's
Okay.
worthless. So I can just tell you that I trust that the field in 5 years will maybe move away from just this transformer hammer that we have discovered. Not to suggest that it doesn't have value, please. That's not what I'm trying to suggest here. It has value. It also has concerns, and you can put together a pretty reasonable video which looks like a politician is saying something they shouldn't be saying today with the existing tools. But these tools themselves are not smart for AGI. So AGI, I think, is decades out, is an optimistic guess. But
it is the critical
Yeah.
limiter here.
Right.
Is it just training, or is it?
It's the algorithms.
Okay.
Yeah. So what our approach to solving is a sophisticated way of pattern recognition. It's not a fundamental paradigm that we have discovered some breakthrough that we can learn as efficiently as humans can learn from less data. You can teach a teenager how to drive in less than a day, reasonably, and then they will at least know that when I'm put into another city, what I shouldn't do. The other thing humans do is we learn from observations. If I see two people dance, I don't have to dance before I can just figure out what they're doing without even interacting with them. So we are not there yet. That's why I'm a little bit cautious on these claims that there's going to be superhuman intelligence. First of all, I don't know if that's a good term to use. But I think the bottleneck is we don't know the solutions to progress from what we know to work today.
All right. Same question.
Yeah.
And just give us a really quick.
Okay.
Is it decades? Yeah. What do you
think?
think?
It's definitely like more than a decade. Yeah, because one thing is a lot of questions. I think this is a good target to pursue because usually you need big question, big challenge to improve your technology or the answers you don't know. But there are basic questions like the kids, you build a tower, you fall. The kids know, okay, like this maybe you do something unstable and there are some physics law you need to learn from this. But our robots nowadays, you cannot learn like just by putting blocks together to learn this physics law. And also like kids, like by watching your parents walking around, what are the things they can help or like what the parents are angry or not. But our robots nowadays, they cannot just watch people for like 1 minute to figure out are they like what they are trying to do or they are angry. So I think there are like these basic components of a human, like reasoning capability or like what's a human like higher level cognition thing still need to solve like more than just like predicting the next words.
Got it. All right. So close out the AI 101 for us here.
Yeah, I just hope we can prove it's infeasible to reach it. That's my answer. I seriously don't really think it's feasible to reach general artificial intelligence. We'll be out of job anyway, so.
We're going to talk about jobs in a second, but so Steven Spielberg in his movie AI was lying to us. Okay. All right, Katie. So you've gotten the rundown from where we came from, where we are, where we're going. And as someone that has really kind of sat on the front lines of the intersection of technology and the impacts and implications and risks of advanced technologies hitting society, what are the main risks that you're thinking about right now? And this is the Center for Politics, and
Yeah.
Larry is Larry Sabato is known for looking at campaigns. And what is your view, political campaigns? What is your view of how all of this capability and the democratizing of AI and putting open source models into the hands of anyone? What is that? Where does your brain go?
Yeah, so I wrote a newsletter a couple weeks ago, and this is sort of going to be my theme for at least the next 15 months, which is we need to panic responsibly.
Okay.
Because, and I'll go deeper into it, but you have some folks out there claiming this is going to be the last human election, and that AI is going to take it over. And then you have folks that are saying AI is going to save the world. The truth is somewhere in the middle, right? But I'm worried that, so AI is going to impact, we are already seeing campaigns use it in ads, right? We are already, and you're also going to see it being used by campaigns to be more efficient. You're going to see them to use it to better help. Like when I was at campaign, if I can have a large language model built off of everything my candidates ever uttered, and I can use that to help me write emails and social media posts and press releases and all of that, like that would be fantastic.
Right.
You could save a lot of time and money for that. Are you going to be able to help folks? Like I even think because I work a lot internationally too. There's a lot of civil society groups that their ability to translate their work into English or translate their work into other languages is going to better help us all kind of learn about how all of these things intersect with one another. But what we're dealing with right now is a lot of fear and a lot of panic of what could be. And I think we absolutely need to be diligent on it, because I think about open source models and I agree with you all about that, but I just keep thinking, oh my God, the bad actors are going to get it. Yeah. They're going to be so much better at it before we figure out the mitigation strategies. How are we going to even figure out how to like catch them? And it's this kind of cat and mouse game, right?
That. Yeah, that's exactly that.
And trying to figure that out. But then on the flip side, I worry about, I don't want Congress or Europe or any regulatory body slowing it down, because you can't put the genie back in the bottle. Like that 6-month pause wasn't going to happen, right? I mean, it's going to have to keep moving, and I think we got to get used to this dance where the private sector is probably going to always be ahead of the regulatory sector. And you're going to need some self-regulation from these businesses. We're redefining what these ethical rules are going to be. And you're going to also need regulation, oversight, transparency, and finding that balance between, rather than being like, this is good, this is bad, because we're not going to be able to agree on what is good and bad. But none of us want the tech companies to be in charge of it. None of us want the governments to be in charge of it, right? And so we're finding this new checks and balances and oversight that we're going to want to have.
Right.
And what I'm thinking about is, this is all happening in the next year when we have all of these elections happening around the world. So for those of you who might not follow international politics, next year is going to be the first year that in the same year as a US presidential election, you'll have elections in India, Indonesia, maybe Ukraine, Taiwan, Mexico, the United Kingdom, and the European Parliament. I'm tracking 65 national level elections across 54 countries. Wow. But those huge number of populations have not, so those elections are going to be happening while we're in our primaries here in the States. And so we're figuring out, Europe's working on, has new regulation with the Digital Services Act. They're working on an AI regulation. I don't think we'll see AI regulation coming from Congress here in the States, but the FEC is looking at rulemaking about whether or not AI should be used in political ads, and companies like Google are already writing policies around this.
Yeah.
And there's a bunch of other factors that are going to be happening with this too. And so we're literally figuring out these kind of rules of the road while you have a lot of people being scared about what could be. It's hard to predict where we might go or not go or how far we're going to be. And so that's why I go back to the panic responsibly, because we should be diligent, but not think like the world's not going to end. We'll figure it out. It's just going to be chaotic.
Yeah, and then there are some complicating factors, and one of them is a question around whether someone that's using a transformer, using a GPT, and is the input and subsequently the output, is that First Amendment protected speech?
Yes.
And it's a really fascinating question.
And copyrighted.
Absolutely. And I think the FEC question, so the FEC is looking at a rulemaking, and there are a number of different groups that have suggested the same, where political content from campaigns or PACs or whatever, if it's AI generated, would need to be labeled as such, the provenance of it.
It's a little bit more narrow with FEC. It has to be whether or not AI generated was making a candidate say something or do something that he or she may not have said. Right now, the way I was reading it this morning, no, so it's not just any generated AI, but that's where the confusion comes.
But see, I think that's too narrow, frankly, because I think it just doesn't have to be the speech element that can introduce
I agree with you on that. It's just the way the FEC works and where they thought they could regulate versus where Congress has to regulate. Yeah. Like there's all this intricacies that people are fighting about right now.
And that, I think I was in Brussels a couple weeks ago for a meeting with members of parliament and other government officials, and this was specifically on the broader kind of challenge of information decay and disinformation. And the European Union's all over it. They've got the Digital Services Act, they have all these regulations, and we don't have the same. And so the Europeans are saying, hey, US, will you work with us on these hard problems? We need some help. And I just kind of looked at it, I was like, you don't understand. Like, you guys are regulate ex ante, regulate before the bad thing happens. In the US, it's ex post, regulate after you've figured out what all the major harms are, make the interventions on the ones that are most troubling, and then in the meantime, you have civil litigation where you can sue the company. And I think that's probably where we're going to get. But I tell you one thing, whenever the private sector, particularly large technology companies, show up on Capitol Hill and say, we want you to regulate us like this, like, that's when Spidey sense starts going off.
Yeah, there's a lot more to that.
I know when somebody's trying to pull a fast one over on me. So, but I think the bigger issue, as we were talking about before, is when it comes to the United States Congress legislating in technology issues, they have, I will diplomatically say, they have underperformed. We don't have a federal privacy law, and it is now up to the individual states, California, New York, Illinois. We are seeing some states, Illinois again, that is intervening in the AI space to protect the citizens. But what do we think the best options right now? And I'll start with you, and then we'll work down the line. What are the right approaches to government interventions here? Do we have even the capacity from a policymaker perspective to really understand? I mean, you've talked about how complicated this stuff is, just mathematically.
Right.
I see us more kind of diverging in terms of where we need to go and where we're able to go. And I think that is part of your point. So what do you think the real, again, let's use 5 years. What do we think in the next 5 years? Because it's not in the next 6 months.
No.
But in the next 5 years, where do you think we can practically go?
I do think Congress will eventually be forced to act after the 2024 election, because you're going to have all these disparate state laws. Right. You're going to have there's these couple of court cases in front of the Supreme Court.
Yeah.
That I think there's going to be enough things that are going to be contradictory that you're going to have something. Congress will finally be able to, and maybe this is me in my glass half full measure around it, but I don't think it's going to be content based. I don't think it can be because of the First Amendment. I do think it's going to have to be more around transparency and oversight. And so the government might not know exactly how, and Congress isn't going to be able to figure out exactly how these things work. But the ability to even know what is happening, how these companies are making these decisions, what the data is that they're being used to train on, doing these red teaming exercises like we saw at DEF CON, where you're able to stress test these models. So red teaming, for those that don't know, is in Vegas here in August, they had, was it like 2,000 people or something like that in a huge room, and they are all trying to hack some of these large language models and stress test them and try to get them to do really bad things and find where those gaps are, because then the companies, that helps them to try to figure out where to go and close those gaps. And so we can't define what success looks like because we don't know all the answers for that. And so that's why I think right now, having at least, to your point, with open source, have it be more auditable and more people that can be...
Yeah, we can red team it ourselves.
Exactly, and seeing all of that, and having government find a way to mandate that of companies. And, listen, I was at Facebook when Cambridge Analytica happened. Those scars run deep. Around
700 million deep? Is that a lawsuit this week?
Yeah. Thank God, not me personally. But I say that because companies are scared of what to share externally. They're scared sometimes because they want some protections because of some of the things that have happened in the past. And so government can play a role in helping to think through. And that's what I'm going to be most curious about with the DSA in Europe and the transparency measures they're requiring. And is that going to work the way that they want it to work? To get more from companies? Or is it going to force these companies, rather than thinking about, I'm stealing this line from one of my former colleagues, are companies going to move away from what they should be doing to be responsible to what they have to do? And the have to do sometimes might be less than what they should do. And how do we think about that unintended consequence when it comes to doing regulation in this space? And
So
stuff?
I like where you're going here, and I want to bring the rest of the panel in, but just kind of putting this into more specific today context. So, and I know it's not generative AI, more ML based, but there's the story from earlier this week, or maybe it was last week, about Alexa
oh yeah, the 2020
devices
election.
that it was you ask Alexa, was the 2020 election stolen, and Alexa would spit out yes, and here's all the things that happened. Turns out it was the training set,
Yep.
the data that it was made access to. I won't get into the specifics of what it was training on, but it kind of goes back to this point of transparency. The second is the importance of explainability.
Yeah.
So where do you think this takes us then? And it maybe explainability for everyone.
Yeah, so explainability is our desire to have the decisions that these models are making be interpretable to us on why they are making these decisions, right? So as has been the recurrent theme, you have millions of these artificial neurons solving these math arithmetic to recognize patterns, and then they spit out that the answer to the question is yes. And so any reasonable person would ask, if it was a human answering yes, why did you say that? And so there is no way for us to examine these black box models yet. And that's an area of academic research in order to make these models more interpretable, try to by red teaming or trying to look at what part of the data was used to inform this kind of probabilistic output. And it's a very tough thing to solve for. So it's, again, it's a moving target, like with all of these things. Like what Katie was saying is absolutely spot on. And I think I should prefix what I'm going to say next by saying it's only going to reveal how ignorant I am of how politics works and Congress operates. But I look at my world, which is self-driving cars, and it's been significant investments in getting that technology, and people were behind it. Industry was spearheading it. There's no regulation. There's no, I am very vocal publicly about that the pace at which the deployment is happening exceeds our ability to understand the safety of these systems. And now this is the next level, right? ChatGPT, if it mispredicts or says something bad, while it can bring down democracy, so that's a pretty high consequences. But if an autonomous vehicle mispredicts, you have somebody, have a tragic outcome, and we've seen many of those. So regulation has lacked in all technological sectors by many, many years, which would be an easy way to say it. But then I'm also, at the end of the day, I feel that these problems are technological problems, and I fully agree that our ability to mitigate them may be far slower than some bad actors' ability to use them, which is really the cat and mouse game. But it has always been that. Social media, forget the AI. AI is just catalyzing what was already happening on social media. You didn't need AI for disinformation. A couple of people on QAnon and some lab in China could do disinformation.
We didn't need the internet for misinformation and
exactly,
disinformation.
Right? I agree with your point. However,
I think
because I thought this too, particularly around election security issues that we were dealing with post 2016. And as I looked at the security of election systems, I was like, this is fundamentally an engineering problem.
Yeah.
It's an engineering problem. The challenge, though,
is policy, right?
Is the adversary looks at it from the other angle. So Russian and Chinese military doctrine for cybersecurity looks at the problem set as it's information warfare. And it's split into two lines. One is technical, the other is psychological. It's they use the technical piece to generate and manifest a psychological impact.
Yeah, so let me maybe linger on that for just a second, right? So disinformation is twofold. It's the production of disinformation, which is part of the problem, and AI is getting good at that. We are getting more photorealistic videos matching audio of a human with very little data. That's where the fears are coming from.
Right.
But disinformation is not just production. A very skilled person who knows Photoshop can probably do a better job than most of these models today with no AI intervention. It's the distribution which is misinformation, right? So, and actually AI is our best tool to fight against that distribution, even today. On Facebook, I'm sure, and Twitter,
Twitter.
Sure. On Twitter,
Sorry.
I said, I didn't say X.
Hey, look, if we learned anything from last weekend, is that the tools with the Hamas attack in Israel, that the tools, at least on certain platforms, again, I'm trying to play the middle here, are not what they used to be or what they should be. Sorry to
Well,
interrupt.
there's a lot of
Notice that I said Twitter, not X.
Yes.
But sure. I'm saying that you catch them, the disinformation, at the dissemination point, right? So the content provenance is a great technical challenge. Can we trace how something was generated and creatively or howsoever edited, but still be able to use some blockchain to trace the provenance of this
Well,
content?
that's where the engineering and the policy and sort of the ethical start to come into play with one another, because then there's the question of, okay, what types of content do you amplify?
Right.
How much reach should it get?
Right.
How are those algorithms working in terms of how that's being amplified? And those are decisions that are being made by humans of trying to, well, part human, part technology, of trying to figure that out. And nobody agrees about that. We don't talk enough about that amplification piece and what goes into that.
Right.
Of deciding what to show people.
But this is also, you talked about the technology element, you talked about the policy element. There's a third element of politics.
Yes.
And we're seeing, I think, across social media platforms, a pullback from where we were in the 2020 election. And part of it is political pressure on campaigns, or rather on platforms, to not have as rigorous interventions and interstitials and labeling because of free speech, which it's a private sector organization. They can make determinations based on terms of service and policy. So it's we're in a really interesting dynamic, at least here. So back to just the general question of where do you see the interventions for good and for bad? And in technology, I generally think regulation's inevitable. Whether it's cybersecurity or AI, it's also inevitable that the government's going to screw it up. This is a truism. It's going to happen that way. But maybe what y'all's thoughts are on where we are and where the government has the best opportunity for success, maybe.
Yeah, I think because nowadays we're talking about black box models. So one thing, the best way we know is about the input and output. So you don't know what's going on inside, so you can regulate from the very beginning, from the input data, or the output is behaviors. And that is the same thing when we're talking about explainability, because there's a lot of things talking about post hoc explain. You are trying to, from the output you get, to figure out what's the inner working of this model is trying to do. So I guess for very short time, this probably will be something what we can, the immediate thing we can do here. But I think we also in the research, we're also trying to work on things how you can do fixing the model, because sometimes the generated thing or it's not facts, or some other things are controversial, so you want to fix it. So there will also be talking about what's the strategy, or what's about the pipeline to go into fixing the specific thing inside the model. And I actually want to talking about some the way probably my ignorance about policy, but I was thinking about the metaphor about the horse metaphor. So AI is the horse you're riding, but you cannot really control it, but you can only know okay, how you can make it turn, or set up the boundary. So I think what we are trying to do is what are the right way to guide it, or set the right boundary, instead of you shouldn't do this, do that, or what could be the right input output. Yeah.
Yeah, again, this goes to that model of technology innovation's inevitable, and we're just hanging on. We're along for the ride.
You need more technologists in politics. That's the slow solution, but that's what you need.
Maybe, Glenn, that's a whole other panel that we can do because look, I think the incentive structures are definitely not in place
There's not
for that,
in place,
and we're just getting where there is like a congressional technology fellow program. And so there are opportunities to go in, but they're few and far between.
Well, I spend most of my job explaining how the policy and politics world works to the tech world, and then how the tech world works to the policy and politics world. And if there's a silver lining at all from all the layoffs that have happened, is you have a lot more people that have worked inside these companies who are now advising governments, advising civil society, advising others to kind of help. One of the most fun things that I do right now with classes and stuff is an interactive exercise where I actually put them in the role of having to develop these policies or moderate content or think about these things, because you get to some really impossible trade-offs around these. And I find that when I go talk to folks on the Hill and stuff, they don't want to go to that really hard trade-off because politically it's a losing battle. And that's part of the reason you're seeing these platforms pull back from politics and news, pull back from some of this stuff, because after 2016, we put in all this time and effort. And I'm not saying be boo-hoo for us, but we put in a lot of time and effort, and we just kept getting smacked around.
Right.
And nothing we did was gonna, you weren't gonna make anybody happy with what you did. And so it's sort of like, and then the regulatory threat hasn't necessarily surfaced in the United States. And so a lot of them are like, why am I gonna put a lot of money into this? And I'm gonna be entertainment. And although what I tell all of them is that everything can become political, and so you can run from it, but you can't hide from all of this. But
yeah, I agree. So I was at Microsoft before I was in the last administration, and my job was playing that translation function between government and the policymakers and the procurement shops, and then what the technologists are doing. And my favorite was with the early days of cloud, and you'd go talk to the Hill, you'd go talk to the Pentagon, and you're like, well, they want more control over their data, and they want a dedicated private cloud. And then you go back and you talk to the engineers, and they look at you, they're like, but that's not how the cloud works. and the response is, well, it is if you want to sell it. And so we're kind of in that spot again, where how much do you lean in on policy making and engaging in the political side to get some of the outcomes you're looking to get. Do we want to take questions or? Oh, perfect. Okay, so we've got about 12 more minutes here, so we can take a couple questions, and I definitely have more questions I could talk about this all day. Unfortunately or fortunately, I'm not sure which one. All right, yeah, go ahead.
I just turned it off. All right. So just at the beginning, I was kind of just pondering on this whole, AI replacing humans in shoot.
Yeah,
it's on. Just hold it closer to your.
And it kind of leads me to the thought, as the human race, why do we always for example, nuclear weapons, why do we play with fire, you know what I mean? And no pun intended with the nuclear weapons, but with AI, I feel like it's the same sort of feel that, the amount of, I guess, damage AI could do to society as a whole is on par with what, nuclear weapons could do, And it's just again, why, as the human race, are we constantly putting ourselves in positions of danger? And I feel like AI.
Yeah, so I think there's kind of a meta point here on, not the company, point on, innovation in technology, tends to result in harms, and how do we control the harms? But then there's a more micro point that you mentioned jobs earlier. So in the meantime, we're creating AI, we're baking it into productivity tools, and in the meantime, what are we doing to ourselves in the workforce and our potential in whatever we do in a daily, so what are the kind of upsides and downsides here? So Fernando, I'll start with you.
I mean, yeah, it's, if you think what powers the United States, energy landscape right now, that's mostly nuclear power, right? So I think that's, there's the benefits of exploring technologies in a certain sense. Then there's going to be bad actors. If there are bad actors, maybe to reconnect to the points that we were making before, also people that are at the forefront of exploring how to contrast those bad actors are typically researchers, as they are acting in the shoes of those bad actors, right, to find out earlier what are the type of challenges. So Congress funding and research. But yeah, so I think that's a critical point. We're always going to explore technology to improve society first. Then that's the benefits that you're seeing. I mean, like even the thought of leaving technology. I mean, AI is not just what you may be seeing, but even optimizing the calendars of flights. You're leaving that behind would just be unthinkable for me, and generally would be unthinkable to forget about that new technology just for the risks that we have them. We're here for making science, and science is may work two ways, but most of the people they want to make science to advance society, right? In the most in the better way possible.
So relatedly, and we've got a couple more questions here I think we can get to, but let's kind of take this point of panic responsibly, and we tend to focus on what are the net negatives, what are the bad things that can happen. But on the flip side, what are the good things that happen? Let's just talk about jobs, right? There's that's one of the conversations that's at least happening in DC is, oh my gosh, AI is gonna replace all these jobs, and people are in the knowledge economy are going to be out of it. But on the flip side, I look at it, and there's more opportunity for AI engineers, AI prompt engineers,
Right.
AI compliance, AI audit. Like it seems to me that there's probably an offset in here somewhere. So what are, as opposed to the negatives we talk about, what are some of the positives for? We talked about drug discovery. You hear about bioweapons discovery. What about drug discovery?
Yeah, look, so first let me tell this gentleman, your question is great. And I love Oppenheimer as much as the next guy. I just saw that too. And I love science fiction as much as the next guy. But this is a very speculative extrapolation that AI is existential, right? Humans can develop technology. The bomb was developed for a purpose of a bomb. We didn't know that we were not developing a bomb. AI, we are developing responsibly. If we actually figure out that this is an existential threat, we will not develop it, right? There is curiosity, and that's what human nature is. That's what I believe distinguishes us from animals. They are not curious about the world, and we are. But let's get back to what you said, the benefits. There's just so many that I can enumerate, but let's talk about jobs, right? So yes, it's true that some jobs will be displaced, and it would be pretty much incorrect to say that. But jobs are getting displaced, I would say, because the incentive structure we have in place is that I can replace someone with an algorithm, and it'll be I can make another better buck. So maybe what we reward as a society has to be introspected a little bit, right? At the same time, AI is going to enable people to learn in better ways, to pick up skills that they never had before. I'll give you an example. It may be a mixed example, but I think it's true. A lot of the creative industry is in a little bit of a dilemma, that I was an artist and I can draw, I can paint, I can make music. Am I replaceable? And if you think about it, art is what? Art is expression of your creativity. And maybe all of us are creative, but we didn't have the tools to express our creativity, and now you have a tool. And you talked about prompt engineering. ChatGPT will spit out garbage. It's up to your creativity to make it work and increase your productivity and make it work as if you have a staff of a dozen people working for you. So it takes that skill too. I think I have that positive outlook that when things get faded out, better things come into place. And this is what I said in the very beginning. Like, we are people who work on AI. We are not designing AI for machines. We are designing it for humans. And humans are good and bad. And that's the battle that has been existing since the beginning of time itself. So there's no clear answers there.
Yeah, I've found that the number of executives I talk to that use some form of AI in their day-to-day, whether it's board members or otherwise executives, it's off the charts. They're all using it, but they're not relying upon it entirely to write their term papers, right? They're using it as a productivity enabler and enhancer. And I think that's going to be the differentiator going forward, is how can we bake these things into our daily routines to 10x us almost? How do we
I've
get
loved
there?
using it to write letters of recommendation. So I just plug it in.
Oh my God!
And then I edit a few, but I work for myself, and I'm now able to use Otter AI to do transcriptions. I'm able to use DALL-E or Midjourney, to your point, of that image that I want doesn't quite exist on the internet to find. I can use that to do all of that. Right. It can help me to get things that I normally would have had to pay somebody to do, or I can just get them done a lot faster, so then my brain power can be used for the analytical piece, the strategic piece, the piece that the AI can't
Abstracts
do.
are great. I mean,
Yeah.
just summarize that thing.
Just knowledge, right? You don't have to, even in Google search, you have to use your brain to kind of distill through the information. Now it's packaged in a different way. It's the same data pretty much, but and that's a risk as well. Do you trust it? Just switch off your brain and just trust blindly what it spits out? No, right? So we have that judgment still. I believe all of us have that judgment still. It's not that we are lazy. I often say humans are like electrons. We like the path of least resistance, as they teach us. But I also trust the humankind we are still out intelligent than the tools we have.
So just one kind of flip side of all this, it's the liar's dividend almost so liar's dividend is whereas the information quality continues to deteriorate, then the ones that are exploiting that space, the liars, actually get a benefit, because when you don't believe anything, they have an advantage here. So one thing that I saw, and I think you can get them on Amazon, are sixth finger rings. So it actually looks as if an additional finger is coming up your hand, because the early models, I know Midjourney's better about this, but DALL-E earlier, the AI models, when they would make graphic renderings, they don't know how many fingers you have on your hand. That's just something they haven't contextualized yet, and they don't know how many thumbs you have, vice, ring fingers and all that. So the theory here is that bank robbers would wear that extra finger, and then when evidence gets presented in court of the the closed network TV.
Do you know what that reveals? It reveals that law that always values eyewitness testimony as the highest standard, and in science we value that as the lowest.
Yes, right. But it's just one of those things that someone's always going to be gaming technology and innovation. Sorry, so we one, and then come here. Yeah, go ahead, please.
Hi, thank you guys for speaking to us. So my question is more about politics and the use of generative AI in elections. So there's been increasing concerns about how generative AI can be used to manipulate voters into thinking either politicians said something or did something they didn't do. And a lot of Congress people have introduced bills involved in watermarking generative AI created election things. Do you think that's enough to kind of combat this disinformation and misinformation campaign that we see from both political sides?
So there's a lot of challenges overall with watermarking or any of the labels and stuff that we've seen, and I think it would be really dangerous for us to just say, slap a label on it. Okay, we've done our due diligence to help people to tell them what's happening, because research is there's still a lot of research that needs to be done in this space. People start ignoring those labels. People don't know what they mean. We don't talk enough about the UX, the user research that really needs to keep being done on what helps people to not only give them more context, but then for them to believe that context, to think about that. And so I think watermarking is absolutely something to explore, but we shouldn't be like, oh, that's just the easy answer. Let's pass the bill. It's watermarking. Okay, we've done our due diligence. Pat ourselves on the back, Congress.
And let's also keep in mind that the bad guys aren't really known for compliance.
Yeah.
And so it's the good guys that are going to comply, and it's the bad guys that are going
Well,
to
that's
exploit
what we
the
have. I
seams
know
in
we're
the
out of
system.
time, but like with political ads at Facebook, after the Russian Internet Research Agency ads, most campaign finance traditionally was, you are a political actor, thus your ads must do this. In order for us to detect that, because the bad guys weren't coming out there being like, hi, we're Russians, we had to start with the content of the ad. And then if the content of your ad was considered political or issue-based, then we were requiring disclaimers, and that caused a huge can of worms that people got all upset by, because now you had non-traditional political actors being asked to put disclaimers on their stuff, and they got all upset.
All right, moderator's prerogative. We're at time, but I'm going to try to sneak one more question in. All right.
Yeah, so I'm a high-performance computing guy. I'm addressing Madhur here. He pointed out that GPUs are transformative in all this, and to let everybody else have some perspective, a GPU in 2012 I could buy for $1,000, which a machine that cost me $3 or $4 million was the fastest machine on the planet 10 years before. So it was really transformative in terms of performance, and that was 10 to the 12 floating point operations per second. Today, the fastest machine on the planet that's publicly acknowledged to exist is 10 to the 18 floating point operations per second. I happen to know that in the next 2 to 5 years, we will have in the United States somewhere between 10 and 15 machines that will be 2 orders of magnitude faster. Okay, so 10 to the 20 floating point operations per second. Do you think that transformation in floating point capability, and they're dedicated to AI, by the way,
Right.
all of these machines, we have 20 gigawatts of AI machines coming online in the next 5 years. So do you think that's going to transform the problem spaces that we're operating in?
Yeah, absolutely. I mean,
Well, how? Should I now be worried? Should I be in full panic mode?
I think Andrew. So I know Andrew, and it is going to be transformative. But what I said before is part of the roadblock of why we are not at Oppenheimer or that kind of a threat yet is that the tools that we have, which will truly solve intelligence, and we can debate whether we should pursue that goal or not, we don't have those tools yet. So that's why it's difficult to extrapolate on what the pure impact of just high compute will be. But if there is precedence, we can say that, what ChatGPT has demonstrated all evening, I have been mostly just bashing it, but I would say, for the longest time, we humans wanted to understand what language is, and it turns out that the model of language is not grammar or syntax or verbs and all that stuff that we learn. The model of language is just the data itself. That's what ChatGPT is proof of. That if you throw enough data, the emergent behavior out of this model is some model of the language itself. It may not be interpretable to us, and certainly we can poke holes. So the worry, if there is any worry, is that will this emergent behavior just scale because of the scale in compute, right? That is very difficult to predict because we don't have the compute yet to say anything.
Anything you'd add there?
Completely agree.
Yeah, I think we definitely need to know if more compute can solve the problem or not. Then we know, I think compute is helping.
Yeah, we're going to need, I think, an update to Moore's Law here.
More people need to be able to have the ability to train these models, not just 6 companies in the US who can spend billions of dollars and train these models.
And I really wish you hadn't brought that up because we could talk about that for another hour. But we're done. So I want to thank our panelists this evening for joining us, and thanks everybody for sitting here with us.